Hello, a very warm welcome to all of you getting ready for WAEC, NECO, and JAMB. Today we're diving deep into a topic that is an absolute gold mine for marks in your exams, sulfur and its compounds. Seriously, if you want to master the key concepts, the equations, and the strategies to ace this topic, you are in exactly the right place. Are you ready? Let's get into it. Okay, so here's our game plan for today. First, we're going to look at why sulfur is such a big deal in your syllabus. Then we'll get into the nitty-gritty, allotropes, the key compounds you need to know, and the big one, the contact process. After that, it's practice time. We'll solve real past questions together. And finally, we'll wrap it all up with a super helpful summary and some killer exam tips. You'll see, this topic is so important because it ties together a whole bunch of chemistry concepts, from the periodic table right up to industrial chemistry. Now, I want you to know that everything we're doing today is pulled straight from your WAEC, NECO, and JAMB syllabus. No fluff, just exactly what the examiners want you to know. We're talking allotropes, key compounds like H2S and SO2, how it's used in industries, and yep, those calculations that you know they love to ask. It's all here. All right, so let's start with the basics. Who is this sulfur? Well, it's a non-metal, and you'll find it chilling in group 16 of the periodic table. Atomic number 16. Easy to understand. Now, a very important fact you need to lock down is how we get it out of the ground. It's called the Frasch process. And why do we bother? Because it is so important for our industries here in Nigeria. I mean, think about it. The fertilizer for our farms, the acid in car batteries, even refining crude oil. Sulfur is literally everywhere. Okay, moving on to a concept that examiners absolutely love to ask about. Seriously, they can't get enough of it. It's called allotropy. If you want to understand sulfur properly, you've got to understand this. So let's break it down. So what exactly is allotropy? Here is the textbook definition you have to know word for word. It is the existence of an element in two or more different forms in the same physical state. You see that last part? In the same physical state. That is the golden phrase. So many students forget it and lose marks. Don't let that be you. Write it down, highlight it, memorize it. It's crucial. Right, check this out. Sulfur has two main crystalline forms, or allotropes. On the left, you've got rhombic sulfur. See that nice octahedral shape? It's the stable form below 96 degrees Celsius. But if you heat it up past that point, it changes. On the right, you see monoclinic sulfur, which has these cool needle-like crystals. This one is stable above 96 degrees. So what's the magic number? 96 degrees Celsius. That's the transition temperature. You need to remember that number. Now, for your exams, there are a couple of key reactions you just have to know. First, when you burn sulfur in air, what happens? It makes sulfur 4 oxide and gives off this really cool blue flame. You can see the equation right there. S plus O2 gives SO2. Simple. Second, it loves to react with metals. You mix it with iron, for example, and you get iron sulphide. Fe plus S gives FeS. These are basic reactions, but trust me, they pop up all the time in theory questions. Excellent work. Now that we have the basics down, let's look at the compounds of sulfur. We're going to focus on the big three that are always in your syllabus: H2S, SO2, and SO3. Let's go. First up, H2S, hydrogen sulfide. Ah yes, the one everyone knows because of that terrible rotten egg smell. In the lab, we usually make it by reacting iron 2 sulfide with an acid, just like the equation shows. But listen, the most important thing for your exams, for both practicals and theory, is how to test for it. And here it is. H2S gas turns moist lead acetate paper black. You have to memorize that test. It's a classic examiner's favorite. Alright, next we have sulfur 4 oxide, SO2. This one is an acidic anhydride. What does that mean? It just means it reacts with water to form an acid. In this case, sulfurous acid, H2SO3. It's also a really strong reducing agent. And just like H2S, it has its own special test. it decolorizes the purple color of acidified potassium permanganate solution. This is another one of those tests you absolutely 100% have to know. Okay, let's switch gears a bit and talk industrial chemistry. We're about to tackle one of the most important industrial processes you will ever study for these exams, the contact process. This is how we make sulphuric acid, H2SO4. Pay close attention here because I can pretty much guarantee you will see a question on this. It's that important. The whole thing happens in 4 clear stages. It's really logical. Stage 1, we make SO2. Just burn sulfur and air. Simple. Stage 2, and this is the most important stage, we use a catalyst to oxidize that SO2 into SO3. Stage 3, we take that SO3 and dissolve it in concentrated sulphuric acid to make something called oleum. And then finally, stage 4, we just carefully add water to the oleum to get our final product, pure concentrated sulphuric acid. See? 4 simple steps. Now listen up. The most critical part for your exam, the part that's worth so many marks, are the conditions for stage 2. You must memorize this. What's the catalyst? Vanadium 5 oxide, V2O5. What's the temperature? It's about 450 to 500 degrees Celsius. And the pressure? Actually quite low, just 1 to 2 atmospheres. The catalyst, the temperature, the pressure. Memorize them. Write them down now. These are free marks waiting for you. Fantastic work so far, everyone. You've got the theory down. But knowing it is one thing. Applying it is how you get the marks. So let's do just that. We're going to solve real past questions now. One from WAEC, one from JAMB, and one from NECO. Let's see how they test this topic. Okay, here's a classic WAEC theory question. It asks for 2 chemical properties of sulfur and the definition of allotropy. See, we literally just covered this. For the properties, you could easily write sulfur burns in air with a blue flame to form sulfur 4 oxide, and then you write the balanced equation. Or sulfur reacts with iron to form iron 2 sulphide. And for the definition of allotropy, you write the exact one we learned. These are such easy marks if you're prepared. Alright, let's switch to JAMB. And of course, it's a calculation. JAMB absolutely loves these percentage composition questions. The question is, what is the percentage of sulfur in sulfur 4 oxide? To solve this, you need to know the formula and how to calculate molar mass. Let's break it down step by step. Okay, here's how you nail this calculation. Step 1, find the molar mass of SO2. The question gives you S is 32 and O is 16. So SO2 is 32 plus 2 times 16. That gives you 64. Step 2, what's the mass of just the sulfur part? That's 32. Step 3, to find the percentage, you just do mass of the part over the mass of the whole times 100. So that's 32 divided by 64 times 100%, and that gives you 50%. Easy. A common trap here is mixing up sulfur 4 oxide, SO2, with sulfur 6 oxide, SO3. So always read the name carefully. And finally, let's look at a NECO question. This one tests your understanding of the concept. Which of the following statements is true of sulfur 4 oxide? The best way to tackle this is by elimination. Let's look at the options. A says it forms sulphuric acid with water. Nope, that's SO3. SO2 forms sulfurous acid, so A is out. B says it's a odorless gas. No way. It has that sharp choking smell. B is out. C says it's an acid anhydride. Does it form an acid with water? Yes, it does. So C is correct. See how knowing your definitions makes these questions so much easier? Oh, wow, we've covered a lot of ground and you've done an amazing job keeping up. So let's bring it all together now. We'll do a quick summary and I'll give you my final top tips to make sure you absolutely smash any question on this topic in your exams. Right here on the screen is a recap of the most important equations we talked about today. Think of this as your personal cheat sheet for revision. I seriously recommend you pause right now and take a screenshot of this. It's got the test for H2S and SO2, the lab prep, and that super important reaction from the contact process. It's all here for you. Okay, so what are my final tips to help you crush this topic? Number 1, Memorize the conditions for the contact process. Catalyst, temperature, pressure. It's free marks, I'm telling you. 2. Always, and I mean always, balance your chemical equations. 3. Know the difference between SO2 and SO3. They are not the same thing. 4. Practice those percentage calculations until they become second nature. And 5. Master those chemical tests for H2S and SO2. They are guaranteed to come up. And I want to leave you with this thought. You have put in the work today. You now have everything you need to walk into that exam hall and confidently answer any question they throw at you on sulfur and its compounds. Believe in yourself. Believe in the work you've put in. You've got this. Now go and get those marks. If you found this lesson helpful, please like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB,